Hello. I'm going to go over a binary search tree data structure algorithm code that I just recently learned how to do. I was practicing on leet code and I didn't really know how to implement or do binary trees. And I did some practice and I just want to share a way that this way that I thought was quite interesting. So binary search trees is or a tree in general is you have a set amount of numbers. In this case, we have 10, 30, 40, 20, 60, and 50. Our first number that we input is going to be our root node. So 10, what a horrible 10, 10. And after that, we will have a right and a left node. And the following values will be, if it's larger, will be put onto the right. If it's less, will be put onto the left side. So in this case, 30 is larger. We would put 30 here. 40, we would traverse down here until we get to, I don't like that 3, sorry. I don't like that either. 30 right here. So 10, 30. 40, we would traverse down the right side. So 40 is greater than 10. 40 is greater than 30. We would put it on the right side of 30. 20 is greater than 10. 30 is less than, 20 is less than 30. We put 20 right here. Horrible too, sorry about that. 60 is greater than 10, 60 is greater than 30, 60, we don't even have to check this side because we would just immediately go onto this side, to the right side. 60 is greater than 40, 60 would go right here. And again, with 50, 50 is greater than 10, 30, 40, uh, greater than 40, but less than 60, we'd put 50 right here. And if we wanted to put like a 5 or something, 5 is less than 10, 5 would go on this side, and all the lesser nodes would go um, onto the left side of 10. So yeah, let's implement this real quick. So first we're going to start off with a tree node class, tree node. And in this class, it's going to be able to take in an integer data. And then we're going to create a tree node of left, a pointer, tree node of right. So kind of like the linked list, how we have uh, next and last. In this case, it's going to be right and left. And then a constructor. So when an instance of tree node is created, we have to pass in a data. And we're going to say data is data. So this data is equal to data. This is essentially what this is doing. Um, this is also saying this left is equal to null. And then this right is equal to null as well. That's pretty much it for the tree node, for the tree node class. Just make this public real quick. So for the actual tree class, define it as tree. Here we're gonna have a couple private variables. Um, First we're gonna have a tree node pointer root. So this is going to be our root, where our root variable is gonna go. So in this case, 10 would go right there. And then we're going to define a an insert function of type tree node. Um, insert. And for this insert, it's going to be a pointer function to point to the memory address of where the new elements should be added to. And in this function, we're going to pass in a node of pointer node and then integer data as well. Sorry, tree node. Okay. So first off, we'd like to check if the current node is null or not. If the current node is equal to null, we return a new tree node with the data that we inputted. Return. So what this part does is, if we take this back to just 10 when we're inputting 10, or even if it's just an empty node, um, our root node, we're gonna later declare our root node is gonna be null. Um, our root, I'm gonna just call it R and null. Our root node is gonna be null. We're gonna pass in our root node and our value, and we're gonna set whatever the first value is to root. So then R is now equal to 10. And this would create since this current node root is null, it would create a new node of type tree node, a new type tree node, and then we would just pass 10. So root would be our 10. I'm going to later show you um, this. Let me just go back to what I just had. Okay. Now, if the data that we're inputting is greater than the current node's data, we are going to go to the sorry, if current data is less than, yep, the if the data we're inputting is less than the current node's data, we are going to go to node left. So we're going to point to the left side of whatever the node is and recursively call insert tree node left and pass in the data. So essentially what this is saying is if the current node is if the data that we want to input is less than the current node's data, we're gonna recursively call the left side until we reach a null and we create a new instance of tree node and pass in the data. So let's say we have a 5 right here, right? We want to pass in 5. In this case, our current node, we'd start at the root node. Our current node is our current data is less than node dot data, which is 10. So we would recursively call left side. And until it reaches null, in this case, it would reach null in the first iteration of the recursive call. It would stop after one time and then call this if statement right here, since node.left, which is 10's left, is null. So this is the left side. This is null. We create a new instance of tree node, and 5 would be inputted here as well. And then this guy would also have 2 branches coming out. All of these would have 2 branches coming out, right? So same with the right side. Same idea with the right side. If data is greater than node data, what is wrong? Else if we're gonna say node right is equal to insert node right. So recursively call the right side with the same data parameter, and then return node, return the node. Return the node that we input, right? So in this case with let's just do 10, 30, 40, and 60. It would call in our current node, which is 10. Say we wanted to pass 70 now. We would recursively call, we would start off with the root node, which is 10. 70 is greater, our data, which is 70, is greater than the current node's data, which is 10. So each one of these are nodes, right? And the variable, the integer number here is the node.data part right here. So node.data is 10. 10 is our current node, our data is greater than our current node. Recursively move right. Current data is greater than our current node's data. Recursively move right again. 70 is greater than 40. Recursively move right. 70 is greater than 60. Boom. This would be a null right here. we would reach this part right here. So this would be root node, root dot right, root dot right, root dot right, or sorry, root dot right, root dot right, root dot right right, root dot right right right, and then root dot right right right, which is right, 4 rights, which would be the null right here. And we reach the fourth right, which is the null. So we create a new instance and then a new instance of tree node and just put 70 right there. Sorry if that's a bit confusing, but that's essentially what is happening here. Now let's create a print method or a function. This would be a void print, and we would take in we were going to pass in a tree node, pointer node as well. We're going to first start off with an if statement. So if node is equal to null, return. So once it's a null, stop printing or stop searching. Then we're just going to recursively call print left, sorry, node left. And then we're going to print the node's data. And then recursively call in, print node right side. So what this does is we're going to pass in the root node first. Recursively check the left side. So start off at root, go to root.left first. Check root.left of the left. If it's a null, stop doing that. Stop searching on the left side. Print whatever this is. So we would print 5 first, and then check the root or current node's right variable. This is null as well. We don't print anything. Then we would step back, go back to the root node, which is 10. We already checked the left side of 10, so we can just print. And then we would check the right side of the current node, which is 30. But before we print 30, we would check the left side of 30, which is 20. Check the left side of 20 first. This is null. We skip. We don't have to print anything because there's nothing here. Come back to 20. Check the right side of 20. There's nothing here. Go back to 20. We can finally print 20. Then go back to the to this node again. Since we already checked the left side, we can finally print 30 because we already checked all the lower value integers of 30. We go back to this node, print it. Now we go to the right side of 30. We can print, before we print 40, we check the left side. There's nothing here. Go back, check 40. Oh, since we already checked 40, we can now print it. Now go to 40's right. Before we print 60, we check 60's left. Boom. Before we print 50, we check 50's left. Nothing here. We can print it. Then we check 50's right. Nothing here. Go back. Then go back again to 60. We can finally print it. Checks 60's right, which is 70. Check 70's left. Nothing. We can print it. And then check 70's right. Nothing. We don't print anything. So 5, 10, 20, 30, 40, 60, 50, 60, 70. That's essentially what this print function is doing. And it's gonna, print the tree in order. Let me format this real quick. Now let me do a search function real quick. So this search function is just gonna return true or false if a value is within the tree. Search, and then we're gonna pass in the node. Sorry, int. No. The root. We're gonna pass in the root. And then a integer data. So whatever variable we're looking for within this tree. First, we want to do a base case. So if node is equal to null, return false, meaning that we've either the tree is empty or we've already searched through the whole tree and we haven't found um the integers that we're looking for. Then we make an if statement if current nodes data is equal to the data that we inputted, return true. So this is another base case. Then we say if uh what is it? If data is less than the current node's data, return the search function on the left side of node and then we pass in data as well. And then finally we would just return if it's not in left side, we just return search on the right nodes and then pass in data as well. Here we go. So here we would pass it in the root node. Say we want to look for let's say 60. We'd pass in the root node. Since the root node is full, there's obviously an element in here. We wouldn't do this quite yet. Now we check if 10 is equal to 60. This node's, which is node.data, which is 10, it does not equal 60. Then we check if 60 is greater than is less than 10, so we can go on the left side. It is not. We would search the right side. We check the right side. Is 60 equal to 30? No. Is 60 greater than 30? Yes. Move on to the right side. 60 greater than equal to 40? No. 60 greater than 40? True. Yes. Boom. This is our current node data is equal to 60. We would return true. We found the node in this tree. And I'll say we wanted to search for 20. We would compare 20 to 10. 20 is greater than 10. Move to the right. 20 is less than 30. Move to the left. 20 is equal to 20, so we return. Now that is it for the private functions. These are helper functions, so we'd have to create a couple public regular functions, air quotations on that, regular functions. So we say public like that, public, and we would start off with a void insert because we really don't need to be passing that much stuff into it. So void insert, and we're just passing in a data, integer data, and in this public insert method, we're gonna oh, sorry, I'm jumping the gun. Firstly, when we create a tree instance of the tree class in the main, we want to create a tree constructor. So we're just going to say tree, and then we want to declare, remember how I had root here as private. We're going to call in root and then pass in null ptr into, why is this red? Oh, sorry. Here we go. There we go. So when we create an instance of tree node, our root node is automatically going to be set to null. So now, with the void insert, we pass in just a integer data, and then we're going to set whatever our root node is equal to insert. So we call the insert, the private insert method function, sorry. And then we're going to pass in our current root, whatever our current root is, and then our data that we want to put into it. Boom. So what this does is, if I erase all of this real quick. So if so when we create tree, root is going to be null, kind of like how I showed y'all before. Null. This is root and this is null. Root is equal to null because of this right here. Root is set to null. When we first do our first passive insert, which is 10, we would pass in 10 to this insert method, which would call the private insert method and do all this fun stuff. So check if the node that we're passing in, which is root, check if it's null. Since root is null, um, we create a new tree node um, class and then just pass in node. So root is equal to 10. This is essentially what this is saying. Now if we wanted to pass in 30, we would pass in 30 right here. Assign root to insert root.data, root and data. We would since 10 is our root already, we really not going to change nothing right here. And then we just go into here and check if the data that we're passing in is greater than or less than the root node. So that's it for the insert method, the public insert method. Now we do the void print. This we would just create void print, and we would just call print within this, which is the private one. Pass in our root, and then that's pretty much it. And then stdc out and oh, this is just for spacing stuff. So void print, we don't have to pass anything in it. We just call it, and then it calls the private print, which is here, and then does all this stuff. And then lastly, bool search. We just pass in a integer value to search for. And for this one, we just want to return, since it is a bool, we want to return the private search with root and then the data that we want to pass in. And that is essentially it for these functions in the tree class. So in the main, we would create tree. To actually run this code, we'd create tree and then just name it tree. So this creates an instance of all this stuff right here. Boom, 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 right? And then root is set to null. So tree dot insert, and let's just do it how we have here with these numbers. 10. Uh-oh, I did not mean to run it yet. 10, 30, 40, 20, 60, 50. Jesus Christ. Sorry about that. 55 and 70. 70. So here we're inserting those nodes. And then let's just call in tree.print. And then just type in the message stdc out. Order should be, or tree should be in order. Tree should be in order. And then let's just do this. And then tree.print, and then let's just do a for the search function. So let's say stdc out searching for, let's search for 60, see if it's in there. Call in the search. Oh, sorry, tree dot search, passing 60. found or not found. And then we can just copy this real quick. And let's just search for a number that isn't even in the tree, which is 100. Search for 100. Okay, so now let's run it. Hopefully it works. Tree should be in order. 5, 10, 20, 30, 40, 50, 60, 70. Searching for 60. 60's in the tree. We found it. Searching for 100. 100 is not found. So yeah, this is just, you know, tree tree data structure um that I just recently learned about and how to do. Um, hopefully y'all understood it. If there's any questions, comments, concerns, if you don't understand it, just feel free to let me know and I'll try my best to explain it to you and some clear things up, right? Thank y'all for watching. See ya.